Hey, so I wanted to come back and refilm this solution. Somebody in the comments had asked a question about how it was done, and I didn't feel like I had time to fully explain what I was seeing when I did the solve of the entire test. So I'm going to go a little bit more in depth and explain this problem as it would go. So the first thing is, um, if you think about, like, let's say I wanted to cut off, let's try to redraw this. I wish I could just replicate the shape really quick. But let's say I've got a square here. I wish they had a blank one. Let's just go a little bit farther out because that one looks like it's not quite enough. And then we'll go here and here and here. And then we'll go about there and there and there and there. Good enough. Okay, so if I wanted to cut off, let's say I use the red color here. If I wanted to say count the path that goes like over to here like that, and it has basically one, two, three shaded squares. The unshaded squares, so the white part would be 22, the red part would be 3. These will always sum to 25. Furthermore, there would be another path, and I'm just going to draw on top of one of these already created ones. There would be another mirrored path over here that looks the same way. And so that you would then shade all of this. And on this version, the white would be 3 and the red would be 22. Now, we don't know how many paths there are that give a sum of 3. I don't think it would be too hard to figure out. You could probably go, cut up here and leave 3 all in a block and then go up the side, so that it looked like this and you were shading this region here. You could do something like that. Let's take a blue that goes over this and a little bit thicker as well. How else could I get 3? I could go over to here and cut off those 3, and that would give me 3. And then obviously that red one would go to white and so forth. So if we just found all the ways there were to get 3 on this side that are shaded, right? They're shaded by the line that you found, the path that you found. They're on the right side of that emboldened line. If you found all the ways there were to get a score of 3, it would equal the number of ways to get 22. And the reason for that is the symmetry effect, right? So if I found how many ways could I get 25? There is one way to get 25. You would have to go like that. And there is also one way to get 0. So in this case, when you get 25, it's white equals 0, red equals 25. On this one, it's red equals 0, white equals 25. But the number of ways to do that is equivalent. And the number of ways that you could isolate 3 is also equivalent. In fact, you would go like this. There's 1. I'll go back and do it again. We'll use a different color like red again. If I go here and I make those 3, there's 2. And another path would be if I'll use red again. If I went all the way over to here and up to there and then over, that would be the only other way to get 3. So there would be 3 ways that you could get 3. And there would be 3 ways that you could get 22 with the white portion being 3. So no matter what you do, the number of ways in which I have a path, it's going to have a symmetric path on the other side that would be the opposite of this one. So like 22 and 3, opposite is 3 and 22. 22 red, 22 shaded, and 3 white. Okay. So observing that access to the symmetry, we could say for every single path, for every path that you make, the white portion plus the red portion is going to equal 25. Always. Then, since every path is mirrored by an equally unshaded to shaded path, so 3 shaded is mirrored by 22 shaded. All of these paths are shaded. What would happen if I added this path to this path, I added those 2 ways, just those 2 ways, what would I get? Let's just take this one block of 3 ways to do this and 3 ways to do that. If I do 3 times 3, I'm going to get 9 shaded. And if I do 3 times 22, I'm going to get 66. That sum is 75. Okay, but simultaneously, I also got 3 times the white, 9, plus 3 times the white, 22, was also 75. These were equal. For all of the paths, your white and your shaded total sums would be equivalent because they mirror each other, right? So if I could just count total number of paths that start here and go to here and add, I take all of those paths, every single one will create a white and red. Let's look at like a chart, right? Let's say my first path, the one we're talking about here, let me just clear screen for a second. My first path, path one way, and I've got white and I've got shaded. We'll call it just shaded, okay? There's one way to get 0 and 25, and there's one way to get 25 and 0. On the next path, the path that you would have 2 empty blocks, there's one way, the other way would look like this. 2 empty blocks. So 2 white, and you would have 23 that are shaded. I would also have 2 ways to get 23 white and only 2 shaded. That would look like this. And then also if I cut it off right here. Okay, so those 2. This is what we're talking about. Notice what the sum of white plus shaded is for every single row that you do. This is a sum, white plus shaded is always 25 for all of these. Now, granted, there are 2 ways to get this 25 and 2 ways to get this 25. But notice that I could just take the total number of paths that I have, multiply it by 25, and that would give me total white plus total shaded. This would equal total paths, whatever that is, times 25. Because for every setup that we do, the sum of these 2 will always be 25. Imagine some path, I don't know how many there are. Imagine one that has shaded as 17 and white as 8. Why is it always 25? Because there's a total of 25 blocks. Your white part and your shaded part will always have that sum. But not only that, whatever this number of way is, there's an equal number of ways that have 17 white and 8 shaded. So by adding up all of the paths times 25, this and this are actually equal. So if I call that X, or A for area, I'm going to call it area plus area is going to equal P times 25. This, the total white part and the total shaded part are both A. They're both A for area, whatever that is, okay? Then because they're equivalent, if I just find this over here, I could simply divide that by 2, P being the number of paths. And that would be your answer. That's what I was seeing when I was doing it. I didn't make a chart, but I saw the symmetry. And so I just thought about how they both would add up to 25 no matter what you did. So if I just counted total paths and multiplied it by the sum of the white part and the shaded part for all paths, and based on the fact that you get the symmetric effect like this, that would mean that half of the total area, basically how many total squares you're adding 25 for, half of that would be the area of all such shaded paths. Okay, so once we realize that concept is in play, the next question becomes how many paths are there? And again, you're going to have to go right 5 times and left 5 times. So it's 10 choose 5 will give you your total paths. Then you're going to have 10 times 9 times 8 times 7 times 6 times 5. No, it's 5 because the 6 was already there. Okay, and then divided by 5 times 4 times 3 times 2. I don't need to write the 1. If you're doing, just a quick note, if you have like 10 choose 3, whatever that number is, that's the number of numbers you write in the top. And then whatever that number is, it's also your factorial as long as this is less than the halfway mark. For example, if I had 10 choose 7, I would never write 7 numbers. I would convert it to this and then write this instead. So it's just kind of a speed trick I've picked up over time. So here I've got 5 and 2 to take out the 10. I've got 4 to take out the 8 and leave 2, 3 to take out the 6 and leave 2. I don't know, 4 times 7, 28, or 4 times 9, 36, 7 times 36, 210 and 42 is 252. So you have 252 times 25. There's a total of 252 paths, each with a white plus black portion that's equal to 25. When I find that total area, half of that total area will be the criteria, the sum of the areas determined by all possible paths. So I can then just divide this by 2. That's going to give me 126. At this point, I usually would convert this to like quarters. Or, maybe you could do this. You could do 2 times 25 plus 124 times 25. But what I would do is I would split the 124 into 4 times 25 and 6 is 31. And then that would let you see 4 times 25 is 100 times 31, 3,150. Answer choice B. Let me know in the comments down below if this method makes sense. Other ways that you could do this. Basically, why did I split off the 2? Because that's a multiple of 4. And by splitting off a multiple of 4 with 25, I just basically get the other number with 2 zeros. That was my idea there. Plenty of ways to calculate that. Do whatever you like. You could even do 1,260, 1,260, and 630, because this is times 10. Basically, you're doing 126 times 10, 126 times 10, 126 times 5. When you do 5, it's just half the 10. So if you have the 10 right here, just cut it in half, add all that up, and you can see 2430, 3120, 3150. Whatever way you want, just try to be creative and not do it like this. That's kind of the least effective way of multiplying in contest math. Just be creative with your processes and you might discover little shortcuts and things like that in there. If this made sense to you, please do leave a comment. If you're interested in the classes that I offer, you can check out the link down below in the description, which goes to my website, and you can also try a class for free. You can sit in on your first class for free. That's offered, goes out to everyone for the rest of this month. So feel free to check it out, even if you don't intend to join. All right, have a good day, and I hope that you enjoyed the video.